Welcome. Thanks for coming to our session about containers on Azure. The title of the talk is Getting Started with Containers on Azure. We're going to go into really some introduction to this topic. It's a very exciting topic. All of us kind of spend a lot of time talking about containers with our customers using Azure. Just real quick introductions. There's three of us here that will be talking today. My name is Brian Redmond. I'm a cloud architect on our Azure Global Black Belt team. So I help customers adopt container-related technology, things like open source and Docker and Kubernetes on our Azure cloud. I've been at Microsoft for 17 years. We can address the last name sort of thing. My last name is Redmond. I don't live in Redmond. I live in Pittsburgh, and that's the way I have to start every talk, apparently. So.
Yeah. It's a real easy transition for you. Yeah. So I'm Joey Schluchter. I'm a cloud architect on Brian's team, specializing in open source and containers and microservices. And I'm from Bel Air, Florida, sunny Florida, hence why I'm wearing a sweater. It's freezing in here. So go ahead, Yi.
My name is Yi Liao. I'm a program manager in App Services team. I'm a PM for all the Linux-related features. I actually live in Redmond.
Yeah, there we go. There we go. Somebody's got to switch last names. We'll do that next.
All right, let's do it.
Yep. So we're big on demos. We like to do as many demos as we can. I'm a big fan of sessions that have more demos instead of more slides. Now, we'll do a little bit of slides and talking really early on here, and then we have a lot of demos for you. We're actually going to start with a demo, except this demo, you're actually going to do the actual demo work. So what we're going to do is we're going to vote on the best programming language. I know people are very opinionated about this. People have stronger opinions about this than many really important world life issues. So what you're going to do to make your vote is you're going to pick one of the phone numbers. You can actually vote for any of these, and you can vote as many times as you'd like. You're going to send a text message to that number, and your sentence that you're going to describe your feelings to describe your vote. Yep. We're going to send that over to Azure Cognitive Services and do a sentiment analysis. And depending on if you say something super positive, you'll get rated really high. You say something super negative, your vote is really low. So we convert that on a rating scale of 1 to 5. Here's a little bit about how the application works. We're, of course, using a lot of different components of Azure. We're running this in our AKS cluster, our Azure Kubernetes service. We have a series of microservices that are taking in a webhook from a Twilio, which is a third-party service and one of our partners that really provides these phone numbers. And again, they're up there in the top right for you to do your vote. So do them as much as you can, scribble them down. You're welcome to vote as much as you'd like. We do feed that into a serverless set of functions running in the cluster using an open source technology called OpenFOSS. And we score it against cognitive services, as I said, and the data ends up in Azure Cosmos DB. What we don't have here is a web application, a dashboard to actually see your votes and decide in the room here collectively who won. And we can take votes anywhere, even on the live stream as well. So we're going to build a web application. We actually already wrote it, thankfully. We wouldn't start from scratch with that. And we're going to use containers to deliver that application into Azure. And we're going to do it really throughout the day. All of our demos will involve this sort of web-based application that we're going to containerize and deploy in a number of different ways. Sound good? Yep. I see a couple of yeses. So let's talk about containers.
Okay. So Brian and I are going to do a little back and forth here. A lot of what we do is relationship counseling between devs and IT ops. So we'll have a little back and forth here. So as we start this out, so I need to write code and not have to worry about IT, all right, and their restrictions, that you give to us, Brian.
Yeah, well, my job is to actually keep the environment up and running. See, the customers actually want the application to be on, and he's always throwing me new versions of the application. The customers just care about the thing being up and running, and so it's a difficult sort of scenario. He wants it updated all the time. I just care about uptime, and we're really sort of conflicting around that, and it's very upsetting. Yeah.
So we all know my code is awesome, all right, and it always works on my machine.
And he does write really good code. Unfortunately, he rarely checks it in, and that's something we really need. But to be honest, one of the big problems we're into is it's great that I have the code. He sort of throws it over the wall to me, but I really need to actually sit down with him and understand how it actually gets deployed. It's a little bit more complex than just some big application. And so we need to be friends, kind of sit down together in front of a machine. Join me, and let's work on this. Let's actually deploy it and get it running correctly.
Sometimes.
Sometimes.
Okay. So we have so many new features and bug fixes that we're ready to be deployed, but we're waiting on you.
Yep. New feature, new feature, new feature, blah, 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 blah. My job is actually keep the environment compliant. Sometimes they put some new package in there. Where did it come from? npm install pulls things from all over the place. What's in there? Is there any vulnerabilities in it? I not only have to keep the application up and running for our customers, but I actually need to make sure it's compliant. I need to make sure that we don't get hacked and be the next sort of big news story. I need to keep it up and running for my customers and so forth. And so it's really important that we address that as well, even though, again, I really do care about getting the new features there. But I have another important job here, probably more important than yours, frankly.
If you say so. Yeah.
So, containers. I'm going to give you this.
Okay. So, as we were talking about that, so it's containers to the rescue, all right? And so a quick show of hands, how many people are actively using containers right now? All right, if I can get through this blinding light, yeah, I see a spattering in the crowd, okay? All right, and so what is a container exactly, all right? So how VMs have hardware virtualization, containers have operating system virtualization, all right? We have a single kernel shared by all containers, all right? The individual container has a view that is independent of all the other containers that are running specifically amongst that. So virtualization versus containerization, all right? Virtualization, you have potential conflicts with your dependencies, and you're interacting with the OS. Whereas a container, it's all packaged up nicely, can be moved anywhere, wherever you want to. All right, and so the container advantage specifically, all right, low utilization of container resources. In other words, hey, I'm just packaging this app and deploying it wherever I want it to, all right? All right, and then you can maximize the density, all right? So migrate the containers and their dependencies, and you want density and isolation. So I'm just going to deploy this somewhere and not have to worry about any of the other things that are deployed with that, and just a ton of cost savings amongst that. And so the key here specifically is immutability, all right? I can just take this and run it anywhere. My machine, your machine, the cloud, on-prem, wherever you want to go, all right? All right, and then as we walk into the Azure Container Technology Stack, specifically what we've got, all right, we want to embrace, the containers. We want them everywhere across our platform, all right? So that you can deploy wherever you want to on any and all of our services specifically. And so as we look at this, we have tons of partner services that you can leverage, some OpenShift news today. All right, and then, Service Broker, which will help you deploy those services and interact with them, all right? So with that, I'm going to pass it off to Brian for a little ACR demo.
Yeah, absolutely. So we build these containers. We're talking about all the benefits to them. How do we actually use them? Well, you do start by building something called a Docker file. This sort of describes what the container is and what actually goes into it. When you use that Docker file to actually build an image, the image is essentially the source for the container. And so I have to store those images somewhere centrally, not only so that they're protected and we're only using images that we want to use, but I also need them centrally because I hopefully am deploying them to a number of different services all over my cloud and potentially lots of clouds. And so with containers, there's something called a registry, and Docker actually is really the one that created this. If you hear a lot about Docker. Docker can mean a lot of different things. They have various tooling to help you create containers. They also created something called the Docker registry. It's an open source project, something that you can download and install on a virtual machine in your environment or anywhere and manage it yourself. Azure Container Registry is a hosted version of that Docker registry. So in Azure, we have a managed Docker registry that we manage for you. We back it with Azure Storage, and we store your images so that they can be available to various services, not just in Azure, but wherever you want to deploy them. It's obviously simple to use them within Azure. We can manage all kinds of different image types, so we support Linux and Windows containers. But you're using that standard Docker registry. So the tooling that you're used to using, if you're using Docker, you might be using various Kubernetes tools like Helm and so forth, or maybe you use Visual Studio Team Services or Jenkins to deploy your containers. This works with those because it's using that standard API. So we're not having some special way of managing containers for you in the cloud. It's just standard Docker registry managed by Azure. But we do try to take advantage of Azure where we can to make it better. And so as an example, we do geo-replication. Because we have regions all over the world, we can actually distribute your images all over the world. And there's a few different places where we do that around security and identity to make that possible. I'll talk a little bit more about that in a moment. I'll show it to you in the demo. But before we do, we kind of think of Azure Container Registry as that central sort of repository for our images as we distribute them to all of those different services. You saw Joey put up that slide about all the different places we can use containers in the cloud. We consider Azure Container Registry to be the central sort of storage for those. You can create them through various different models and distribute them to various different services. Typically, when we release a service that supports containers, we make sure it supports Azure Container Registry first. But certainly, you can use Azure Container Registry. We could have a block up there for Google Cloud, Amazon Cloud, your cloud. It's available anywhere. Now again, one of the things that we do to make it easier to use ACR is we integrate Azure Active Directory. And so when you log into this Docker registry, we don't want another identity for you, another identity store. And then since it's an open source platform, we had to integrate the Azure AD credentials. And so when I want to do Docker push and Docker pull, which is how I move my container to the registry or retrieve one, I can use my Azure AD credentials. I can log into Azure and then do an AZ ACR login, which I'll show you here in a moment. And then I can start interacting with that registry. And my Azure AD credentials is only going to let me do that with registries I have rights to. And that's super powerful. We do also support service principals, which are our Azure service accounts. And so we can also use those to interact with the registry. And that's important when I start to do things like CI/CD. And I have some automation with the environment. I need that automation tool to be able to grab images, store images, and so forth. And we use service principals to do that. I mentioned geo-replication. Again, we're storing these images in an Azure region. When you create a service, you're putting it in a particular region. In this example, I'm out in West US. I store an image. If I were to deploy that image in East US or Canada Central or over in Europe, I have to pull that all the way across there. It's slow, and perhaps more importantly, it costs extra money. And so geo-replication essentially just automatically replicates it to the regions I choose. And then when they get pulled, it just pulls it from the closest possible location. And so in theory, I would just pick those regions where my applications are being deployed, and they'd always be pulled from the closest location. It's so easy to set this up. I'll show it to you in a moment, but you're just clicking on the map and picking the ones you want it to be replicated to, and it just happens. There's not anything else you have to do in your sort of environment to do that. Another thing that came this week actually was announced a new feature to ACR called ACR Build. And so typically, in order to build a Docker container, you have to have a Docker service or a Docker daemon in the background to do the build. And so you're setting up these special build environments. You need some kind of build machine to do that work to have that Docker engine available. Maybe it's a developer workstation for some experimenting, but again, in an automated environment, I have to have some place to go do that build. Well, ACR, since you're going to be storing your images in ACR, why not have ACR take care of the build for me as well? So I end up pushing my code up to the cloud, and the build occurs there. And of course, since I'm already there, easy enough to store the image right there in ACR and make it available the normal way. This is very cool technology, something I was very excited to see. I now use this all the time. Now I can just be in a browser-based shell, Azure Cloud Shell, which I'll show you in a moment, and just quickly do a build and have it available. And just to give you an idea, again, before I jump into the demo, it looks just like Docker build. So if I type Docker build -T, which stands for image, I don't know why -T stands for image, the AZ ACR build uses the same syntax. And there's other parameters that are typically a part of a build, and we tried to map those sort of end to end. ACR build also supports triggers, so you can trigger it off of an update to a Git repository. You can trigger it off of a dependency update, so maybe the underlying base image got patched. We can trigger builds off of that. So I'm going to show you a real quick demo of ACR here and a little bit of ACR build. There are certainly more sessions where you can learn a lot more about ACR build. There's sessions we'll point you to at the end of the talk here. So ready for demos. So this is my local machine, and if I was going to do any kind of container builds, I have some images on the local machine. And you can see I have a bunch of different images here. I'm always building images. I'm speaking at events, and I'm building various images. I have to do all of that locally. And if I wanted to run a particular container, I would type something like docker run, and it's saying, hey, I'm ready to run, you just need to give me an image and so forth. You're going to see when I switch over to Azure Cloud Shell how I can't do something like docker run or docker images. These commands aren't available to me in that Cloud Shell. And so that's why it's important to, obviously I can do this locally, but I don't really want to be working in this local environment. I don't want to be having to make sure I have these things here for me. And so if I want to interact with ACR, I do an AZ ACR list, and it'll show me all of the Azure Container Registries I have rights to. So I have 2 in East US and 1 in East Europe. I have them all 3 as the premium SKU because that's how I roll. And we're going to basically log into one of these. So I do AZ ACR login. I have to give it the resource group. And I give it the registry name. It's called Breyer ACR Build, which stands for 2 things. It stands for the Build Conference, and it also stands for the new feature called Build. And so now I'm logged in, and if I wanted to pull an image from ACR, I'm going to show you how to do that. Let me actually show you in the portal the images here. If I go over and take a look at this registry I just logged into, we're going to pull one of these images. So this is my portal experience. You can see I can see some basic information about my ACR, my quotas, and so forth. I click on repository, and we'll see an image, and we'll pull one of these. And so I have this one called K8S Helm, this particular tag. And so I'm just going to cut and paste this command a bit to make this easier so you don't have to watch me type. And so I say docker pull. I obviously have to have credentials to pull this. And what did we type wrong there? Could be a typo. Doesn't really matter, but obviously I need to have rights to pull that because it's a private registry. And so doing that AZ ACR login gives me rights to actually pull from that, and that takes care of all that credentialing for me. If I want to push an image up there, I could take one of the images that we have here. And I could say, hey, I want to take this particular SMS ratings. That's actually the one that was collecting your votes that we were doing earlier. If I want to push that up to ACR, I first need to tag it. And so I do a tag, and then I do a docker push. And so it starts pushing it. Again, I would need rights to do this. It's already taken care of that for me. This is simple for just a simple interaction here. I did have to build it on my local machine. There's a big process to this, and that's not really the kind of the ideal scenario. What we really want to do is actually take advantage of this ACR build. And so in my Azure portal, I have this utility called Cloud Shell. Hopefully you're familiar with Azure Cloud Shell. But it is a virtual shell that's just running in the browser here for me. It has all the Azure tools that I need. It's already logged me into my Azure subscription. Makes it very simple for me to take advantage of anything that comes available in Azure via the Azure CLI. And so I'm now logged in. I can do some of the same things like Azure ACR list. And you can see those same ones that I have access to. And so in this directory that we're using for our demo, I'm going to show you a quick Docker file, and we're going to build it. And so very simplistic sort of format if you haven't seen a Docker file before. I mean, typically it's just start with this source image, copy in this particular source code, run these various components to get the application installed, and essentially this is where the app starts. And I would normally type something at this point like Docker build, and typically when you do that, you're going to see a message like this. Hey, Docker isn't running here. And because this is a virtual environment, I can't run a Docker daemon here. That's a privileged service and not something that's possible in Cloud Shell. And that's where ACR build comes in. We can do that Docker build just by passing, and I'll paste this here and then I'll explain the command. And so what I've said is, do a build. Here's my image name. I give it a build rating web. I give it a tag called live stage, and I say the context is this current directory, and I tell it the registry I want. And I said no log, so it's happening. It's been queued. It's happening in the cloud now. I could just sit here and wait for the result, but we can actually use the Azure CLI to get status for this. And so I put a watch, and I say, show me the builds that are happening. And you can see I've ran lots of builds here. But our build idea here is AA2A, and you can see it's currently running. And we can tell approximately how long it will probably take. It'll take it about a minute. and we can wait for that status to complete. We could also check it, and so I could come into this, kill that watch here, and I could get some details about the build. It was AA2A. And it's saying, hey, it's still running, so we're waiting for that to actually finish. But I can actually see the logs. I don't really have to wait. If I go in and type that same command, actually, that wasn't the actual image name, so let's get the one we're waiting on. And so you can see what's actually happening. It's pushing it right now. So it did build the image, and we're just waiting for that to complete. And you can see that we'll end up seeing the status here when it's actually completed. I'm going to show you what it ends up looking like when it's done. And one thing I want to point out here, and this is the last thing I'll kind of say about ACR, but look down at the bottom there. It finished the build, and you may not have seen all this before, so a lot of it's out of context. But at the very bottom, it said, ACR builder discovered the following dependencies. The image that we built, and then this runtime dependency, which turns out it is based off of the node base image in this particular tag. Well, that's going to be useful later. Imagine that particular image has a security vulnerability. ACR build can be triggered off of any base dependency updates. So it's detected them, and it's very simple for me to use that later to do those kind of image updates. And so you'll see more about this if you want to go to the talk that's a super deep dive. Steve Lasker will talk about ACR Builder and a lot more about it. You can see some of those other scenarios. I just did a basic build here. We will use that image in a moment when we deploy this to Azure App Service with containers. And so let me jump back over to the slides here and keep us going.
So I was backstage feverishly voting for JavaScript. So, okay. So what we're going to do now, we're going to walk you through actually deploying that specific website to Azure App Service. Let me just switch this around real quick. Ryan, I apologize. There we go.
Can we do the slides?
Okay, the slide is right there. Okay, there we go. All right. And I'm going to switch over real quick to mine.
Yep.
I'm 8. Okay, so just to walk you through that. So the app is currently available right now. If you go out to GitHub, github.com/Azure/build 2018 container demo, it'll walk you through specifically running this entire app all by yourself, okay? Just some key points behind it. Right? It's running Cosmos DB instance, all right, with the Mongo API behind it. All right, and basically, it's got 3 parts to it, which I think Brian showed you some of those specifically, all right, or 4 parts to it. So you've got the web, and then you've got 3 services that are underneath it specifically that are running in AKS. So I'm just going to go show you those services running out there on AKS in Brian's cluster. So, what's that? Okay. Okay, so those are out there running. There's a ratings one, there's a sites one, and there's a subject. So the subjects are, hey, the different programming languages. The site is actually, hey, how do we lay this out specifically? And then the ratings are the ratings themselves. And so within there, you can on that GitHub repo, you can go and grab all the data that you need and everything that's involved in this specifically. All right. So we need that front end, and so. Prior to this, I had also set up some that are not running in AKS out on App Service, just to set that up. And so
I can do a quick introduction about the app.
Yes.
All right. So let's
go ahead and talk to that.
Oops. Switch back to. Right. So I just want to make an introduction to App Services so how many people actually use Azure App Services in the room? Oh, that's a lot. Thank you. So this is just a quicker introduction about Azure App Services. Azure App Services is a fully managed platform. It includes a set of application services, so where you can actually deploy your like a Windows app or Linux apps to the service. And we support like different type of application stack, such as Node.js, PHP, .NET Core, and Java. So it enables you to be highly productive. So basically, you can only have to worry about your application code, write your application, and you don't have to worry about the infrastructure, which is host your app application. And also, you don't have to worry about scaling, as we will taking care of the scaling based on your business needs. So this also, we provide high availability and also guaranteed SLA if you run your application on app service. App service is an end-to-end application platform. So it has, we support different type of application services such as web apps, API apps, and mobile apps, which makes it super easy for you to build, deploy, test, and eventually host your application on app service for your API apps, for your web apps, for your mobile apps, etc. So Azure Function is another service we own, which Azure Function lets you to deploy a serverless application to Microsoft Azure, and you will only be charged for the time your application code is running on our platform, and you also don't have to worry about scaling because we will scale on your behalf when you need it. So app services actually started on Windows platform a few years ago. We're very excited actually. Now app services is available for Linux applications as well. We made an announcement, general availability announcement last September. So now you can actually deploy your application to your Linux application to app service as well. With Azure app service on Linux, so you can deploy your application written in different languages such as PHP, Node.js, Java, and you can deploy your application to app service in a few literally seconds. So you don't have to worry about the infrastructure, worry about scaling, and you don't even have to worry about the containerization. So we're taking care of everything under the hood for you. For web app for container, this is a different use case. This is where you can Dockerize your application in a Docker image. You can host the Docker image in Azure Container Registry or Docker Hub or your own private registry, and you just need to point your application to there and deploy it to us, and then we will run the application on our platform for you. So with web app for container, so you have the flexibility of manage your source code the way you want. You can manage your image repo any way you want, but you still get the full benefit of app service as a full management service. You can use, let's say you can use Azure Container Registration or Docker Hub to host your image. You can set up a continuous deployment from your source repo. You can also set up a continuous deployment with a webhook, which trigger a deployment when you make a change. So also we provide built-in support for Docker logs, and you can get those built-in diagnosis informations from the service and troubleshooting your apps. So now I'm going to switch back to Joey, and he's going to show you how easy to deploy a pretty complicated app to app service.
Okay. All right, so Brian actually built you saw him built a container image with ACR build, all right? And so we're just going to deploy that web front end. Frankly, I want to see the results currently, So let's go ahead and walk through that. And with the help of Yi here, we're going to create a simple web app, all right?
So this is the portal, Azure portal. So there's Joey just go into the entry point where you can start to create a web app. He's typing in the name for the app. Okay. So that has to be unique. So he's choosing the right name.
Okay, go ahead and use that, and I'm going to choose Docker.
So he's using the web app for container. So we made some UI changes, make it easier for you to start to create a web app, any container-based application.
Okay, and so I'm going to choose Azure Container Registry.
Absolutely.
And so through the magic of AD, Brian has granted me access to that repo. All right. Oh, so we have access to that. He's granted me access to that specifically. So I'm going to go through and pick that image that he created, and it is where is it at? Build rating web. Fourth one down. Okay, there we go. And the actual tag is going to be live stage. Okay, so we're going to say OK on that. All right.
Now we need to create a service plan to host this application.
Okay, so that service plan specifically, we're going to go ahead and create a new one. All right.
So just we made several announcements yesterday. So we're adding different type of skills for you to host the Linux web app.
Okay. So I see this. Is it? I get free 30 days?
Oh yeah, you get a B1, the first B1 for free for a month from today on.
Okay.
Try it out.
Yeah. All right, so I'm going to choose that one. Basic. I'm going to put this in West US.
Anywhere you want.
Okay. We'll go West US.
Sure.
Pretty close proximity here. Oh,
you need a name for that.
Yeah, AS plan, live stage. How about that? Okay.
Good.
All right. And then we've already got that. And so let's go ahead and say create. All right. And so that normally, through the magic of cooking shows and Martha Stewart, guess what? It's already there. All right. Fantastic. It's up and live, and you guys can go there. It's build-web, azurewebsites.net, and it's using all of that. And frankly, we all want to see what the leaderboard is, right? I have a sneaky suspicion it's going to be Microsoft heavy. So there we go. Right now, C# is that 200? Nobody likes JavaScript. Why not? So, yeah, there's no surprise there with C# leading there. Okay, so with that, you saw the ease in which you could deploy a simple container. And so now, with that, I'm going to let Yi take over, and he's going to show you how to do something a lot more cooler from there. So,
thanks, Joey.
All right, thanks, guys.
So with Joey's demo, you can see how easy to deploy this application to app services on Linux or web app for container in literally a few minutes. So we have thousands of customers actually use web app for container to build their application. They also ask for, like, can I actually have multiple containers running on the same app? For example, they want the use case where they want to put an Nginx in front of their web app in the same app service plan as a reverse proxy. Some people also say, can I have a Redis cache which is sitting in between my web app and the Azure MySQL database, right? So for those use cases, we just made an announcement yesterday. We are supporting multi-container in web apps. So with the new multi-container web app feature, you are able to create multiple containers within the same app service plan, but you can operate all those containers as a single unit. So next, I'm going to show you how to use multi-container to build the same application as Joey demoed. In this time, instead of deploying multiple web apps, make them talk to each other over public internet, I'm going to deploy all those containers in the same web app. So now I'm switching to my Linux machine, which is where I'm going to do a demo from. So first, I want to show you the source code of Joey and Brian's demo. It's on GitHub. As usual, PM always do the things up front. So I already cloned the feature, or cloned that repo locally, so it can show you where it is. There you go. So now, in order for me to deploy this to a web app, multi-container, so I need to create a Docker compose file. Because in this, remember, in this public preview release, we support two types of of configuration format. We support Docker Compose format. We also support Kubernetes config format. In this demo, I will use Docker Compose. So again, I already created this Docker Compose file, YAML file up front. So you can see this is how you describe. So you just use Docker Compose format. You can describe a multi-container app. So in this case, I have 4 containers. The first one is the web front, and also have 3 other containers for APIs. So with this Docker Compose is ready to go, I'm going to switch back. And before I actually publish to app service, I want to test it locally, right? Normally, people would want to debug, find any issue locally before you actually push it to a service. So what you can do here is, like you can do a Docker Compose up, and I'm pretty sure a lot of folks in this room are familiar with that. So you can just run that Docker Compose. And what's happening under the hood is the Docker Compose is pulling all the image from Brian's repo right now on this stage lifetime. So it takes a little bit of time to pull like 4 images. Once the image is pulled down locally, and it will run that YAML file I just showed you guys, and create the application running on my desktop. So now the front end is running, so I'm going to just quickly show you the local version of it to make sure everything is working correctly. So we're running off port 8080, so that's where I'm going to hit. Here you go, it works locally, great. So let's try it out to make sure it actually works as expected. So let's do a voting. Sorry, no offense about who is more favorite about which language. I'm just randomly choosing. Sorry, oops. Yeah. Okay, so still working? Let me do it again. Okay, I presume it's working locally. Let's move forward. So let's deploy this same application to the service. So let me kill that. So now what I need to do is run a CLI command to deploy the YAML file to app services. So instead of type everything in front of you, so I just pull from history. So here, you do a AZ web app create, and you need to specify a resources group as usual, and you also need to specify a app service plan, and also give a name for the app. And then you specify this is a multi-container config, use compose file. And then you just type it, also give the path to your file, and then you just need to run it. And it will take a couple of seconds to actually push this to app service. Yep, this time it will work. Oh, it works, there you go. So now let's go back to the actual application running in the cloud, running actually on, so this is actually running in the app service plan in US West. So let me show you this time. I'll give you more for JS. Oh. Okay, so there's something going on. Okay. All right, so let's, I think this is a demo, and again, we will make sure the application is working before we actually publish the source. Right. All right, so now let me switch back to the slides. So with all the demos you saw on app services, definitely app services give you choices, right? So you can use different language runtimes, like we mentioned .NET, right? .NET Core, Node.js, PHP, Java, and we're adding support for Golang and Python later this year, right? You can also use different type of application platform templates, WordPress, Drupal, etc. And definitely on the deployment side, you can put your image, on Docker Hub or Azure registration, or you can use, let's say, you can also use like a CI/CD pipeline software to help you to manage your deployment, like Jenkins and everything like that. So app services definitely give you a choice. And one thing I want to mention before I hand over back to Brian is we have a session this afternoon at 4:45. And my colleague Jennifer Lee, she's going to present how you use the diagnosis features on app services. So if you guys are interested, go join her at 4:45. All right.
Awesome. Thanks, G.
Thank you.
Yep. Cool. Nice. Yes. So yeah, very cool technology, regardless of we didn't get to see the final leaderboard. I'm sure C# continues to win. The great thing about that is, we didn't have to think about all this infrastructure happening behind things. That's one of the advantages of app service and using PaaS kind of technology. We have some similar functionality in our Azure Kubernetes service, or AKS, giving you that ability to host a Kubernetes-based cluster and not think about all of that overhead. Certainly, sometimes we just want to run a container. I don't even want to think about a complex orchestration system. I don't necessarily have all of those needs. I just have a container and I want to run it. And really, that's where Azure Container Instances comes in. In some ways, I just need a container. And I probably need Clippy to come along and help me through that. It's kind of sad. Clippy has this legacy. I'm sure there was some person on the team that thought up Clippy, and I'm sure they had really great ideas. And I don't think it was that terrible of an idea, but unfortunately, Clippy will be around as a negative legacy forever. But what do we need? I just need serverless containers. I really just want to run a container and not think about any infrastructure at all. And so when we say serverless is certainly a popular term thrown around a lot today. I'll tell you what I mean when I'm thinking about serverless. The first thing is that it's invisible infrastructure. There's obviously infrastructure behind it. There's physical servers. There are virtual servers. There is all of that that's happening there. But from my point of view, running the container, that's invisible to me. I not only don't see it, I don't have to see it, I don't even know how it works, and I don't want to know. I don't want to be responsible for having it up and running. I just want to run my container and ignore that kind of detail. I want some metrics back from it, perhaps, about my container. I want it to be treated as just that resource. The other big characteristic about serverless is microbilling. The concept that I only pay for the seconds while this particular container is running. If I run it for long periods of time, I pay for long periods of time. If I run it for 3 seconds, I pay for 3 seconds. And so that's really important to that serverless concept. And the third area is it's event-based. It's event-driven. Some event occurs that triggers this to actually execute, and my container runs and does its work. It perhaps actually triggers other events and so forth as well. And so I have this kind of serverless sort of concept. And we want to apply that to containers. We built this container maybe to do work for us. I want to quickly kind of get that up and running. And that's what ACI is for us. I easily can run serverless containers. I don't think about that infrastructure. There is some sort of infrastructure everywhere in the Azure cloud. And I basically run a container as a first-class resource in our cloud. In the same way that you use virtual machines. And you create maybe a distributed set of VMs in the cloud, and you do various things with them. You're doing the same thing with containers here. I just have a container that needs to do some work, run it for me, and our customers maybe do all kinds of interesting things with it at that standpoint. And again, I get billed per second based on the resources that I'm using in the cloud. The other thing that's really important that we provide with ACI is we have isolation at hypervisor level. So you're not just running in some farm alongside other customers or even other resources that you're deploying. You always have hypervisor level isolation. But you still get that super fast startup time. Obviously, if we created a VM for every one of your containers, booted it up every time you started one, it might take us minutes to start your container. And you'll see when I do the demo, it's not minutes, it's seconds. The speed of containers starting is one of those big benefits that we talked about at the beginning. I still get that speed, but somehow I also have that hypervisor level isolation for it, which is critical in that serverless kind of environment. So what can you do with Azure Container Instances? Well, you can do anything you want. Really, once you understand kind of how it works, you can build interesting solutions. We do find customers doing these kinds of things, and it's fun to kind of learn about what customers are doing with it. I certainly have modular apps, some of the things that we've been showing today. I have some components running in Azure App Service that maybe are web app related. I may have some batch processing component in the background doing some work for me. I may have another component running in a different sort of area. And so ACIs can help me in these applications that have a number of different components distributed in the cloud environment. Lets me take advantage of containers in a simple way. Certainly event-driven apps. I may have some kind of workflow. There may be some webhook occurs. I may want to kick off some sort of process and have a container run and do work for me. And certainly that's a very obvious use case for using ACI. Batch jobs and things like that are very common in this kind of scenario. The other thing that's also interesting is elastic bursting for something like a managed cluster AKS or Azure Kubernetes service. I have a set of nodes running this Kubernetes cluster. We haven't talked a lot about Kubernetes today. But to expand the size of that cluster, I've got to add VMs to it. I'm going to actually use ACI to be a way to have that elasticity of that cluster without actually adding VMs to it. And that's very exciting, cool work that the team has done. I'm going to show you here in a moment what that looks like. And so let's do some demos here of ACI. Of course, my Cloud Shell timed out. Wouldn't be a Cloud Shell thing without that. So before I wait for that to come up, we'll go and take a look at my resource groups here and just take a look at my container instances that I have running. So I don't have any container instances deployed at this point, so we're certainly going to go in and do some deployments around this. Let's go over and take a look at my Cloud Shell. The same way that in the portal, we could see all of the containers that I'm running, I can use the Azure CLI to do the same thing here. And so if I type AZ container list, I bring it back as a table. I don't have any containers. And so we're going to go and do a deployment. The scenario that I'm showing here, just again, going back to the demo, we had these programming languages. We all voted for them. Imagine that we wanted to do some interesting analytics around the votes. So we wanted to take the summary of the votes, maybe the total votes and the average score by time, and take it over to another analytics system in the cloud. We have all these interesting analytics solutions in Azure. Maybe we can do something where we compare it to the number of bugs reported in these particular platforms and decide, did the votes actually vary based on that, and do some sort of analytics around it. And so I need some sort of job that's actually going to pull that data out of Cosmos DB and maybe write it over to HDN site. That's an example of something I could do. So I have a container that maybe I want to run every once in a while and do that sort of data export. And so that's what this container will be. It is actually over in the GitHub repository. We called it build ACI demo. And so this is a very simplistic JavaScript application. It goes out to Cosmos DB, and every few minutes or every few seconds, it grabs the latest summary and is going to push it over to this other database. To be honest, this is a simulation. It really just logs it to the output here. We're not actually going to HDN site, so it's a little bit of smoke and mirrors, of course. And so you can see I created the container. Notice all I had to do to supply to create this container. I said, here's the resource group, here's the name of the container. I supplied memory and CPU resources that I wanted, and I gave it the image name. Very simple from that standpoint. I didn't supply any networking information, public IP addresses and ports and so forth, because it's not a web app. But I certainly could. It could automatically generate a DNS name for us. It can open the ports that I want to and make this container available if I want. So if we go over and take a look at my container instances in the portal, I refresh here, we'll see a container instance, again, this ACI test that we just ran. To be honest, I waited too long to come to this. It's already running. It honestly was probably running within a second, up and available. You can see some performance statistics. It'll take a few seconds here for these to actually show up in this display here. But I can see some details around the containers that are running in this container instance. You can actually have more than one container in an Azure container instance. So we actually refer to it as a container group, and they run collectively on the same virtual machine. But notice we get some details not only of the status of the container, but the events that have occurred. And so perhaps I put in the wrong image title, or I didn't provide credentials to pull from things like ACR. We would see those events here, and it helps us from a troubleshooting standpoint to see in the portal actually what's happening. We can get some properties around things, so there's a lot more that I can provide here that I'm not using for this demo. I can map volumes and storage to this container so that the next time we bring this up, maybe we stop this, I bring it up again, I'll have access to those same files that have been stored there, and they'll come online as well. I have environment variables. That might be how I get access to the database. I may supply those as environment variables instead of having them in the source code and so forth. So I get all of that access here from that. I also have access to the logs. And you can see it's a series of errors, which is all fun. So that probably tells us why the leaderboard didn't come up. We probably caused issues on our database on the back end. Kind of fun. So this is a container instance that's running. It's actually executing for me. As soon as I were to go in and delete that, we would actually stop the billing for that. But let me actually bring back up the Cloud Shell and show you some of the other things. Especially since we had an error, it's actually kind of good. We can actually go and do some troubleshooting around it. So let's take a look at the logs and see what's actually happening with this. So I have access to the logs for the container. So this is helpful. Something went wrong here. Go through the logs, find out what's actually happened here. Not only could I see the logs for a particular instance and scroll through it and see what's going on, but I can actually stream the logs. And so if this was a long-running transaction that doesn't stop, I can actually do an attach here. And it'll just stream the logs. And as things start to happen, if anything additional comes in here, we'll continue to see it. This thing is looping every 3 seconds and trying to do something on the database and continues to get the same error. So it's an opportunity for me to troubleshoot and figure out what's going on. I can even exec into the container and do some troubleshooting in the container. I'll just show you real quick kind of what that looks like. Oh, and notice by the way at the bottom it says, warning, you have restart policy set to always. So what happens is something went wrong with the container and the ACI has restart policies that we can set. I can configure that to say, don't restart it always. If something goes wrong with it, I actually want it to stop and report back a status. And so that's some of the features that have been added to ACI as it was released to give me that. But I can do things like exec in and have a bash prompt in the container and maybe see what's going on. And so I say AZ container exec. I point it to the container and I tell it I want the command bash. If you've worked a bit with containers and Docker and Kubernetes and so forth, this looks very similar. You exec into containers and do work like that. I do this and I'll end up with a bash prompt. And perhaps because it failed, I won't actually get that prompt. And so again, we have to go in and kind of troubleshoot what's actually happening with it. So that's the ACI from a simple container. A couple other things I want to show you. Again, when I delete this particular container, I will immediately stop from a billing standpoint. So we ran there maybe a total of 5-6 minutes. From a billing standpoint, I'm no longer being billed, it's gone. And I may have some sort of process orchestrating those things being run. I may actually kick this thing off a few times a day. I have to have some other system to take care of that for me. And there's a lot of things I could do. I could use Azure Functions to trigger the execution of one of those. You can imagine a lot of scenarios where we could kick these things off and take advantage of ACI. Now, I want to tie back to what we were doing earlier with Azure Container Registry. You may have noticed in the demo, I used a container from Docker Hub, and that's a public container registry where I can just store an image. Perhaps I actually want to use ACR, like we showed earlier, and so I can actually do that, but I need that service account credentials to access ACR. I can't just have ACI having built-in rights, at least in the way that we have it today. And that's where we take advantage of something called Key Vault. If you've used Key Vault before, it's a way to store particular keys and values such as passwords so that I can use them in applications and services to access things. And so I have this Key Vault. My Key Vault is actually called the same thing as my ACR, and so my Key Vault is called Briar ACR. And before the demo earlier last night, I actually put the keys for my ACR in this Key Vault. And so we don't have to sort of go through the tedious commands of me going in and executing that. So I want to show you actually what a container create command looks like using Key Vault. And so I've set some environment variables. You'll see when I do my container create, I'll use these, but I'm just telling it resource group, Key Vault name, ACR name, and I'm going to call my container ACI with Key Vault. We're going to use the same image that we used before, except we're going to point it to the one that's running in ACR. So I did that AZ container create before, but now I'm specifying my image as briaracrbuild.azurecr.io and the container image and tag. And so now it would have to have rights to do that. And so I've said, here's my registry username and password. Grab them from Key Vault and actually do the execution and create this for us. And we kick that off, and we'll actually see this thing get created pretty quickly. So again, I want to be able to have this done securely. We can certainly do a lot of different mechanisms to do this, but again, containers start fast. This is really important to Azure Container Instances to take care of work like that for us. If I go in and do my refresh here, you can see I have this up and running. I click this. It will probably be at a running state pretty quickly. We're at creating. Typically, again, these things are starting within seconds of this to be up and running. And so it's, again, going out and doing that same batch processing work, but now we pulled it from a secure location. And that's important to note. You don't really want to be running containers from Docker Hub. You don't want to be storing your containers there. You want to store them in a way that's secure. And there are a lot of other ways to make sure that you used safe images as well and scan them and secure them. Lots of solutions for that kind of thing as well. So that is ACI. I'm going to come back to my slides here. Just to summarize from a feature standpoint, I showed a few of these. Obviously, I can create and manage them in the portal. I did it with the CLI here, but you can actually do it with a portal experience. You can say new container and supply all those same parameters. You saw the sort of CPU and memory and performance statistics, so we can see things like events that are occurring and the streaming of the logs and so forth. Again, I mentioned the restart policies and things like volumes to be able to have storage to persist data that can be used the next time this thing is run. And of course, we have an SLA because this ACI service actually went GA, I think it was last week. And so we now are general available with this technology. It's very exciting stuff. One of the other ways that we can use Azure Container Instances, I mentioned this elastic bursting. So we have something called the ACI connector for Kubernetes. It's based on a technology called the virtual kubelet. And so if you've worked with Kubernetes, the sort of agent component of it is called the kubelet. And so if we could somehow take advantage of this technology called ACI and tie it in with AKS and Kubernetes, we could do some really interesting things. We now have that rich orchestration capability that Kubernetes offers, but we get the infinite scale of Azure Container Instances so that maybe our applications, they run in Kubernetes, some components of it actually run over in ACI. And I want to show you in a picture what this looks like. So this is an AKS cluster running Kubernetes control plane. I have 4 nodes in this cluster, and I'm running various workloads or containers on those virtual machines. In the Kubernetes world, we call containers pods, and so I'm distributing various applications. There is a point where I've actually run out of space in this cluster. I could add nodes. I could scale this cluster up easily from 4 nodes to 10 and so forth, and AKS makes that operation very simple, but maybe this is where I can take advantage of ACI. And I add this thing called the ACI connector as a virtual node. And now when I push containers or pods to that ACI connector, instead of running on a VM, they actually run as Azure Container Instances. Very powerful from that standpoint. Essentially what I now have is I have 4 virtual machines as nodes, and I have the 5th one as a virtual node of unlimited size. I can spin up as many as I want. They pay for them while they're over there running. I have this burst of demand. They spun up very fast. When that demand goes away, I delete them. I've stopped paying for them, and that ACI connector 5th node becomes free. There's absolutely no cost to it while it's not running. And all I have to do from a Kubernetes standpoint is direct pods to that node. There's nothing special about it. It actually acts and looks like a standard Kubernetes node. So that's what the ACI connector is all about. You can learn a ton more about the ACI connector and Azure Kubernetes service at a session later today by Gabe Monroy from our product team around containers. And I highly encourage you to go see that session. There's lots of great stuff in there. I'll direct you in a moment here with a summary slide about where those sessions are and so forth. So kind of to summarize, we started today talking about, I guess, relationship counseling for IT and DevOps. Hopefully you sort of see that standpoint that these technologies actually immerse those teams together. If you're working with containers, you're not sort of having the app team build something and hand it over to the operations team. It's impossible to work with this kind of technology without working together. So whether they like each other or not, or whether they're used to working together or not, we're going to be doing it by taking advantage of containers in Azure. Today, these are the services where we use containers today, particularly on the right-hand side of this slide. You saw a few of them. You saw App Service for containers. We saw Azure Container Registry as that base storage component and build component for our registry, for our images. We didn't see Service Fabric or AKS. We saw a little bit of AKS. But you can go learn about containers on those platforms as well. There are sessions around that. You can use containers in Azure Batch. We certainly saw the usage of Azure Container Instances. So a lot of different ways to use containers in our cloud. And we continue to, we expect this to expand. We expect containers to be everywhere in our cloud, and we expect that to sort of be everywhere eventually. So again, resources to get started. I mentioned Gabe Monroy. Their blog post came out yesterday with some of the exciting announcements that we made here at Build and some of the really interesting innovation that we've done around this. And it's a great blog post and a lot of great technology that happened there. And there's also some great sessions at Build that you can go learn more. Why Kubernetes on Azure. A couple of these were yesterday. So again, you can catch the recordings on some of them. There's probably more around containers than this list, but these are ones we would encourage you to go to. The source code, the Git repository that we showed, based on the demos that we had, is at aka.ms/buildcontainers. You can find Brian and Joey on Twitter at those. Yi is on Twitter, but he's not as big a Twitter person. So please feel free to follow us, and you'll hear more stuff about containers. And we're down at the expo. We have booths around all these different technologies. We encourage you to come and check things out. So with that, I do want to give people a chance to ask questions. Please come to the microphone, and we'll get Joey and Yi to come back up. But we certainly will take questions. I appreciate everyone's time. We have about 10 minutes or so to take some questions, so please do. Yeah. Questions?
Any questions?
For which metrics?
App service or?
ACI, yeah. So the question was the metrics that are shown there in preview mode. Yeah, so that's my container itself. Again, it's running on, there's an underlying virtual environment that's running that has CPU and memory usage. But I really, as a container, I just want to know about CPU and memory. So it's just collecting those and exposing them through the portal. I can stream those and see those. It's data that's available through the Azure API. But it's actual usage. Like you saw when I created the container, I said I wanted 1 CPU and a gig of memory. But that graph and that chart shows actual usage. So if they're just kind of dormant and sitting there, you'll actually see that and see the actual usage of them. Yeah, so people often, when they're talking about containers, talking about things like Prometheus. And so, yeah, you can stream this data to kind of some back-end platform. And we certainly have Azure Monitor, a place to look at data there as well. And so we'll have our services doing that kind of thing, storing data in Azure Monitor. Question right over here on the left, or your right.
The normal app service has like limited CPU and memory. What is the limitation on memory and CPU for each container?
So all your applications are running on a single VM, right? So if you have a single container, we have some overhead, right? We need to run our service. So you probably get most of the share. So in your application, if it's multiple containers running on the same app service plan, all your containers are share those resources as well. So you have to be mindful when you choose the size of your VM, basically the SKU.
So it's still the same limitations of what I think it's like 4 CPUs and 14 gigs of RAM, I think is the max.
In the past, we only support the basic SKUs and the standard SKUs. So you can go up to let's say I believe it says 7 gig that's memory and 4 CPU that's at most. But in this yesterday we announced the support premium SKU for app services in Linux. So you can definitely, I think you can double the capacity there. So go check out the premium SKU, and also we have now we support app services environment for Linux as well. So go check those out. So those are give you more scale, if you want to scale out to more instances.
Question? Oh, yeah, question here.
Yeah. That was all great on Linux. What about us old-timers stuck with Windows containers?
Yeah, great question. And we get a lot of questions about Windows containers. And yeah, these services, we're moving to have Windows container support happening everywhere. As you may know, Windows containers came with Windows Server 2016. So if you think about the way containers work, we used kernel functions inside of the Linux kernel to create the actual containers. That actually had to be built into Windows. And so that's been done, and that work's been done. But now these services, like for example, Kubernetes, actually now need to be modified to support Windows containers. In that blog post, they actually announced a preview of using Windows containers with AKS, so you can try it out there. You can find support for Windows containers in various components of Docker as well. And we support those on App Service. I'm not sure.
Yes, you actually, we are in private preview right now for support Windows container on App Services. Yeah.
Okay. You can also run it on ACI right now.
Yeah,
if you wanted to.
Great point. And Service Fabric actually supports Windows containers today. So when I talk to customers, they say, I want to use Windows containers production enterprise ready today. Service Fabric is probably the place to start because it really is the one that actually has a sort of production level SLA support for it.
Hang on, this guy right over
there. Oh yeah, over here.
Yeah, right
Sorry,
side.
I'm blinded.
Yeah.
Is the container registry available on the Azure stack? So for local hosting?
That's a good question. What I would ask you to do on that was come down to the expo. The team will be down there. I don't know, and I'm often unfamiliar with what is on Azure Stack and what isn't. I have blinders on a little bit about that, so I don't know. I'm not going to take a guess.
Yeah, so actually yesterday, Steve Lasker, it is in the works. So if you go to the expo hall, Steve Lasker will be there, so will Sejan, and they'll be able to talk to you specifically about that, okay? About the plans for that, so.
So my question is more on the app service isolated environments.
Yes.
Is the container available on there and can it be used?
Yes, actually, we just made a announcement yesterday. So now you can create Linux apps in ACE, in App Service environment. So you can create a ACE you can create a Linux app in its own ACE, or you can actually create a Linux app in the existing ACE alongside with Windows application. So your Linux application will have access to the resources on the same VNet.
What about the registry?
What about
container registry? Will it be inside the VNet as well?
That's a good question. So I think you probably talk about if you want to have a private registration, you want to host it in the same VNet. Yes, you can definitely do that. Yes.
They'll probably, with something like a Azure Container Registry, since it's like a managed service, they'll probably work for managed endpoints for it. That's kind of the way that we typically take, like, I think Azure SQL is the first one to have that managed service endpoint. So it's not like it lives in the virtual network, but it's a way to keep that public endpoint inaccessible from the outside. And that's probably where we would go with ACR as that new capability comes to all the different services.
Any timeline?
For managed service endpoint?
Yes.
Not sure. It may just be I'm not close to that. That's definitely something we can find out.
Yeah, we can find out with Steve.
It's in the future. It's in the plans.
Agreed.
Yeah.
Thank you.
Right here.
Thank you.
So I know that Windows 10 using native virtualization, we can run Linux and Windows containers. I was wondering if we can run Windows containers on Windows 7.
Wait, Windows containers on Windows 7. Not natively. So that support for containers in Windows, again, came with that Server 2016, which effectively maps in the desktop world, I think, to some version of Windows 10.
Yeah.
And so there's kernel functions. They're called like C groups and namespaces because containers look and feel like a virtual machine, but they're really just a process on that machine. And so from their point of view, I've abstracted those concepts of file system and processes for a container. And so they would have to backport all of that kernel functionality to the older operating system. I don't think that kind of work is on the radar. I think we try to bring people over to the current time. Now, it doesn't mean that on Windows 7 I can't run a hypervisor and run a container engine that can support those containers there. And that's probably your best bet.
Oh, so like creating Docker machine.
Yeah. So you'd be on Windows 7. You'd install some sort of virtual machine technology, whatever that may be, and then run a Docker, something that supports it, like a Windows Server 2016 or an updated. And get that.
Your best bet there is VirtualBox.
Yeah.
It's just that's going to be your best bet. Install VirtualBox, then install Windows, along those lines. So.
Okay. Thanks.
Question here.
Web app with Windows containers. How can we get that private preview?
Okay, so the best bet is you can go to the expo hall, and I will be there, and I can hook you up with folks that can help you out.
Okay. Yeah, just look for the app service.
Yeah, look for the app service booth.
Yeah.
I will be there.
Okay. Thank you. All right.
Question over here.
So I'm actually looking at some features which are provided by console for application configs. Is there anything that is provided by Azure containers for having application configs like environment configs? For example, I'm connecting to a service and I want to switch based on environment or maybe containers.
So you're talking about like configuration management for the container, like the containers connecting to a particular database in this environment and sort of configuration management for them?
Yes, and the shared configs.
Yeah, I mean, like, whenever I run into that, I would typically turn to something like AKS to help me. Because AKS is based on Kubernetes, it has the concept of config maps, which is a Kubernetes solution, but again, we're managing Kubernetes in Azure with AKS. So config maps, the application just says, I'm going to pull my configuration from the config map, but depending on where I've installed my application, that config map could be different. And that's how I would end up driving connectivity to different things.
Okay.
Does that make sense?
Yeah, but will it work with Docker containers, Docker images?
Yeah, so the containers that are running in Kubernetes are Docker containers. And so actually somewhere under the covers in Kubernetes, it all ends up referring back to whatever container engine you're running. The default is Docker, but they actually support other container runtimes in Kubernetes. That's actually one of those sort of pluggable, extensible things. But it is based on Docker as the sort of default. And so there are all Docker images, even though Kubernetes is doing the orchestration.
Okay, thank you.
Mm-hmm. Well, it looks like we don't have any more questions. We're just right on time here, so I appreciate everybody joining. I know most of the people have headed out, but yeah, it's a good time to talk with everybody about this. So we'll see you at the booth. Thank you.
Thank you, guys.
See you guys at the booth.
All right.